CADEM softwares. www.cadem.net. You are requested to watch this video in full screen and high resolution. Welcome to CademPVD. In this tutorial, we will design a simple pressure vessel, say a gas filter. You can also view this tutorial on an HTML web page on the link in the description. You can download a trial version of CademPVD from our website and try out this tutorial alongside by yourself. To begin with, click on the Equipment menu and select Pressure Vessel. Let us now fill all the appropriate details that need to be filled in the displayed equipment configurational dialog. Since this vessel's axis is vertical, the dialog's definitions, the front end and the rear end refer to the top end and the bottom end respectively. For a vessel on saddle supports, with its axis horizontal, the front end and the rear end would refer to the left end and the right end respectively. This pressure vessel has a top flat cover and a bottom dished end. The top cover is of a bolted type and is connected to the shell through a top body flange. Select True for the front end flanged entry. This will ensure that the top flat end is connected to the shell through a body or girth flange. The pressure vessel is provided with lug supports and lifting lugs. Click on the OK button. Update the project details in the Properties window. The equipment will be added to the current selected project in the Project Explorer, with the equipment name, Gas Filter. Under the entry Gas Filter, a tree list is generated wherein various details for the equipment can be seen, defined, or updated. Click on the entry Gas Filter, which by itself is a major definition entry wherein the major configurational or dimensional details are defined. You can update the contents in the Properties window in case you need any changes. A simple pressure vessel like this one has only the shell side design data. First, enter the operating condition data. Note that the pressure units are kilogram force per square centimeter gauge. After updating the operating condition information, proceed to updating the design condition information. If the user desires a hydrotest pressure greater than that required by the code, he can update it in pressure and temperature hydrotest. Select the applicable radiographic examination. We shall let the software choose the default radiography as required. Update the allowances information. This process completes the definition of the design data information. The user can edit the wind and seismic code parameters if required. The user can also change the wind and seismic code selected if required. The next step is to add materials of construction for various components. You can define the materials of construction for the various material types in the common areas and thus save time required in defining materials for each individual component. The definitions of materials are covered under the Equipment subtree, Material Specs, in the Project Explorer. Let us begin defining materials for the main vessel components. For this, select the Material Spec combo box on the left side vertical menu strip and select from the list of predefined material specs or datasets. The software user can update, add, or modify these datasets. The next step is to define the materials for nozzles or the connections. This completes the material definitions. While following the above procedure, you have noticed that you have done minimum definitions or entered minimum inputs. The other entries have been left blank or empty and the software will select appropriate values for them. Let us now proceed to the design of the equipment. Click on the Equipment tag to select the equipment to design in case there are multiple equipment in the project. Now, select the submenu Design Equipment in the top menu Design Model to begin the design of the equipment. While the equipment is designed, any design warnings or errors that occur are displayed in the Errors and Warnings window. The warnings are displayed in black color and any severe errors are displayed in red. In the case of warnings, the user can review them and take necessary corrective action if required. While in the case of errors, the user has to take necessary corrective action for equipment design to proceed further. You can notice that there are certain warnings only and there are no errors is displayed in the Errors and Warnings window. For the moment, let us ignore the warnings. The next step is to see the design output. Let us proceed to see the design output for the top bolted cover item, bolted cover front. The design output is displayed in the Output window. Click on the shell flange front object. Generate the report for it by selecting the submenu Code Report from the top menu Create Report. This will display the design report for the shell flange front object. The shell flange front object design shows that we have selected the flange material as plate material and it also shows the bolt diameter and number of bolts required. Let's change the flange configuration to forged SA105 of a fabricated weld neck type, which should have M36 bolts. Click on the shell flange front object and update the flange type and design method to integral. Let's proceed to setting the bolt size to M36. Select the submenu Design Equipment in the top menu Design Model to redesign the equipment, and thereafter check the shell flange front design output. After designing the overall equipment, we now proceed to adding nozzles for the equipment. After entering the details in the above nozzle schedule dialog, click OK to update the model. Now, select the submenu Design Equipment in the top menu Design Model to redesign the equipment. The Errors and Warnings window is displaying an error in red color, which is a severe error. The design cannot proceed further unless we rectify this error. The error has occurred in the Nozzle N03, which says that the provided neck thickness is inadequate. Let's resolve this error by selecting a higher schedule for the nozzle neck. Proceed to redesigning the equipment. You can click on any item or object in the equipment and see its design by selecting the submenu Code Report from the top menu Create Report. Create the design reports for the Nozzle N01, the main equipment gas filter object and the main shell object. You can change between the unit systems MKS or FPS or SI dynamically by selecting the submenu Option Unit System in the View menu. The user can input values in the MKS system, then switch to the FPS system and generate the design reports. You can click on any item or object in the equipment and see its design by selecting the submenu Code Report from the top menu Create Report. Now, if you want to design the equipment with the same design conditions but with a different diameter and length, then you can enter the new values in the main equipment's properties window. You can redesign the equipment and check the design reports for the main shell, lifting lugs as well as the lug support objects. You can view the design report in the PDF format by selecting the submenu, Print Preview under the File menu. You can save this design report in the PDF format, or you can take a printout of the same. You can also save this design report in various formats by clicking on the Save Report option under the File menu. This completes the tutorial demonstrating the design of a gas filter pressure vessel in our software, CademPVD. Thank you.